In this video, you're going to learn how to differentiate an algebraic function of the following form: y equals ax to the power of n, where a is a constant, so it's just a real number. So for example, numbers like 1, 2, 3, negative numbers as well, -4, and so on. N here, the index of the variable x, is also a constant, and x is a variable. Examples of functions that take this form are as follows: y equals 2x to the power of 3. In this case, you can see that the coefficient of the variable is 2, so a is 2 in this case, and n, the index of the variable, is 3 in this case. Another example, minus 3x to the 5. In this case, a is equal to -3 and n is 5. I'll give you another example, y equals x to the 4. In this case, you can imagine that there's a 1 in front of the x to the 4. So it's the same thing as 1 times x to the 4, which is the same thing as x to the 4. So in this case, a is 1 and n is 4. So this function is the same as y equals x to the 4. So you always have to remember that you can introduce a 1 in front of the x because it doesn't change anything. So in this case, a is 1 and n is 4. I'll give you another example which may not seem like an example at first sight. Y equals 3. Well, y equals 3 is the same thing as y equals 3x to the power of 0. If you've done the algebra course, you'll know from indices that any number of variable raised to the power of 0 is 1. So x to the 0 is equal to 1. 2 to the power of 0 is 1, and so on. 3 times x to the power of 0 is the same thing as 3 times 1, which is 3. So in this case, a is 3 and n is 0. You can also have a function which is a combination of expressions of this form. For instance, if you're given this equation or function, y equals 3x to the power of 3 plus 2x to the power of 2 plus 4x. In this equation, each of these terms are of this form. In this first case, a is 3 and n is 3. In this second case, a is plus 2 and n is 2. In this third case, a is plus 4 and n is 1, because x to the 1 is the same thing as x. So be careful, make sure you are able to identify that functions of the forms I've shown you and something like this are examples of functions of this form, and I'm going to show you how to differentiate functions of this form. We're going to find the derivatives of functions of this form. Now we're going to take a look at the procedure for determining the derivative or the differential coefficient of an algebraic function of the following form: y equals ax to the power of n, where a is a constant and n is a constant, x is the variable, and y is also another variable. So y is a function of x. The symbol for the derivative or differential coefficient is dy dx. When you have a function where you have an equation where y is a function of x, the first derivative is dy dx. That's the symbol, and it's given by a n x to the n minus 1. So what is this saying? This is a times n times x raised to the power of n minus 1. So all you have to do is, from this expression, you take a, constant a, multiplied by the index n, then you have your variable x raised to the power of n, then you subtract 1 from the power. So it's a and x to the n minus 1, which is what we have here. So I'll just do a quick example. So for the function y equals 3x to the power of 4, you can see that this expression is of the form y equals x to the n. As you can see, a is 3 and n, the power of the variable, is 4. Therefore, the derivative, also known as differential coefficient, which is dy dx, is going to be equal to a times n, so 3, because a is, and in our case a is 3, times n, in our case n is 4, times the variable x raised to the power of n minus 1, n is 4, so raised to the power of 4 minus 1, so dy dx, so the first derivative of this expression here, this function here, is 3 times 4, which is 12, times x to the power of 3, and that's all. I'll change the function to x to the 5. Your first derivative is obtained by first multiplying the power by the coefficient of x, the constant coefficient of x, which is 2 in this case, so a, so 5 times 2 is 10. You write your variable, and this 5, which is the power of x, subtract 1 from it. So you have 10x to the 4 as dy dx. If this is the first time you're handling differentiation, it's safer to write out your expression compared to the required form. Note down the value of a, note down the value of n. So for the first derivative, just replace a with its value, n with its value, and of course n with its value, and don't forget to subtract 1. So what does this derivative mean? Take for example, like if I tell you that dy dx is equal to 2, what does that mean? So let's start with a function. Y is a function of x, and that function is as follows: y is equal to 2x. So this is a function. I can plot this on a graph. So I'm just going to sketch my axes. I'll just focus on positive y and x axis. So I wanted to plot the graph of y equals 2x. I need a table of values. So I'll write x and y values here. I'll just write down a few. I'll just focus on positive values of x just for the sake of demonstration. So let's start with x being equal to 0. When x is 0, y is equal to 2 times x, which is 2 times 0, which is also 0. When x is 1, y is equal to 2 times x. Okay, I'll just make it clear here. So this y, the function, y is equal to 2 times x. That means whatever x is, to determine the corresponding value of y, you need to multiply the x value by 2. So when x is 1, y is equal to 2 times 1, which is 2. When x is 2, y is equal to 2 times 2, which is 4. When x is 3, y is equal to 2 times 3, which is 6. So I'm just going to quickly plot that here. Use a different color. First I need to label the axes. I'll use white. So this is the origin. This is an x value of 1, an x value of 2, an x value of 3, an x value of 4. Here I have the y value of 2, the y value of 4, and the y value of 6. So I'll just plot the graph. When x is 0, y is 0. When x is 1, y is 2. X is 1, y is 2. When x is 1, y is 2. When x is 2, y is 4. When x is 2, y is 4. When x is 3, y is 6. When x is 3, y is 6. So the graph looks something like this. It's a straight line. Now I'm going to demonstrate the meaning of this expression. dy dx is equal to 2. It says for a change in y, if you divide it by the corresponding change in x, you get 2. So I'm going to start with a point on this graph here. This is the point 2, 1. So I'll call it point A. It has the coordinates, well, an x coordinate of 1 and a y coordinate of 2. And I'm going to move to another point here. This point I'll call B, which has an x coordinate of 2 and a y coordinate of 4. So point B has an x coordinate of 2 and a y coordinate of 4. So imagine I'm moving from point A to B along this line. Remember, this line represents this function. I'm moving from point A to B along this line. What's the change in the y value? I'm just going to represent that with dy, delta y. So what's the change in the y value? So I go from A to B. So I go from a y value of 2 to a y value of 4. The change in y is y2 minus y1, which is 4 minus 2. So this is y2, this is y1, this is x2, this is x1. So the change in y is 2. So I move from a to b, and my change in y is 2. What's my change in x? That's x2 minus x1. So x2 is 2, and x1 is 1. So my change in x is 1. So what is dy dx? What's the change in y divided by the change in x? Well, the change in y, as you can see, is 2. The change in x is 1. So the change in y divided by the change in x is equal to 2. So without complicating things too much, you can see that what this dy dx does is it just tells you how y changes with x for this function, with this function still being obeyed. If you pick another point, if you move from B to C, I'll just demonstrate that. So this is point C here, which has an x coordinate of 3 and a y coordinate of 6. Now, let's determine dy dx. So imagine I start from, well, let's start from A. So I go from A to C. So let me just mark this out as C. Imagine I go from A to C. From point A, I go to point C. So I'm moving along this line, so this function is still being obeyed. What's the change in y? I'll just do that here. What's the change in y? It's y2 minus y1. Or if I call, this is what I'll do. I'll call this y3, and I'll call this x3. So I'm going from A to C. I'll call this x1, and I'll call this y1. So I'm going from A to C. The change in y is y3 minus y1, which is 6 minus 2, which is 4. The change in x, so I'm going from an x value of 1 to an x value of 3. Change in x is 3 minus 1, which is 2. And if you don't agree, think about it. I'm starting from a y value of 2, and I'm saying the change in y is 4 plus 4, which means it increases by 4. So 2 plus 4 gives 6. Here, the change in x is 2, which is plus 2. So you're starting from an x value of 1, increasing by 2, which is 1 plus 2, which gives this x value of 3. What's dy dx? Well, dy dx in this case is simply 4 over 2, which is equal to 2. So the notation is dy dx, and there's a reason why I actually use this symbol, delta. And there's a reason why this symbol exists, but I'll be going outside the scope of the Y syllabus if I explained. So just understand the idea of the first derivative. It just tells you how y changes with x when one moves along the, if you think about it, the graph of a function tells you how y changes with x. And you know that if you move along the graph of the function is obeyed at every single point you move on. So if you move from A to B along this line, you're obeying this every single point coordinates. The coordinates of every single point you pass through satisfies this function. So as you can see, I've shown you just by going from A to B and from A to C that dy dx is always 2. So imagine there's a certain function. So y equals f of x. I don't know what this f of x is. So for instance, this f of x could be y equals 3x squared plus 6, or who knows, it could be any expression, but I don't know what it is. So I'm just focusing on y is equal to f of x. So for a certain function relating x and y, so y equals a function of x, this relates x and y, dy dx is 2x. So you're told that dy dx is 2x. The derivative of that function is 2x. Question I ask for the value of dy dx when x is minus 3, 0, and 3. So for a certain function, we need to determine the value of dy dx when x takes some certain values, because in this case you can see that dy dx is actually itself a function of x. As x changes, the value of dy dx changes. So first case, when x is minus 3, what is dy dx? Dy dx is equal to 2x, which is 2 times our x value, which is minus 3, which is equal to minus 6. In case 2, so we've solved this. In case 2, x is 0. So in case 2, x is 0. What is dy dx when x is 0? Dy dx is equal to 2x. Since x is 0, it's going to be 2 times 0, which is 0. So when x is 0, dy dx is 0. I'll do case 3 quickly. In case 3, x is 3. So we need to find dy dx when x is 3. Well, dy dx is 2x, so dy dx is equal to 2 times 3, which is equal to 6. So you've just seen that dy dx changes as x changes for this certain function. Unlike the case where I told you that for a function dy dx is 2. For such a case, the derivative is constant.